in today's video I have brought you a very nice problem of Yugoslav Mathematical Olympiad edition 1980. Here is the following setup. Find all x as a positive integer, satisfy this following equation. We have x to the 5 minus x equals 6 minus x to the 1 minus x as an exponent. Okay, in fact this is very nice and interesting problem. It's not a hard problem, but it has a smooth trick. Once you find the trick, it will be easier to solve. Okay, so I would be recommend to give that try to this problem prior again to the solution. Go ahead and pause this video when you come back to see the solution. Okay, by the way, don't forget to hit the subscribe button and support the channel. Share and subscribe and help other people as well. Okay, so as you know, more activities on video makes the video be seen by others. Okay, so I would be recommend to increase the level of activity on this channel. So now let's jump into this one to see what's giving us. Okay, so before we proceed with the solution, as you know, the exponent sometimes be negative. Okay, so be careful here when you raise the exponent. Now before we determine the status of this equation, we are going to determine the domain range for this one. So in order to determine the domain range, we are going to apply the natural log on both sides. Okay, that's what we are going to do. So I get the following. I get 5 minus x is multiplied by natural log of x equals 1 minus x is multiplied by natural log of 6 minus x by natural log rules. Okay, now it's very clear here. We know 6 minus x must be strictly superior than 0 because it is inside of the natural log. Also x must be strictly inferior than x must be strictly superior than 0. Okay, so we have two things here. We have x must be strictly superior than 0. Also we need 6 minus x must be strictly superior than 0. Okay, so this one is giving us 6 is strictly superior than x. Let's put this one together. I will have x run from 0 and 6. Since we are dealing with a positive integers, we are going to include number 1 and 5 here. So which means x must be live in this interval 1 and 5. So we have determined the range of x. We have determined the inequality where x lives. Okay, between 1 and 5, including number 1 and 5. Now let's name this one as an inequality number 1. So now I'm not going far away from this one. I'm going to multiply both sides by -1. So I get the following. So if I'm going to do that, the inequality, it will be changed the direction. So this one becomes minus 5 is inferior to equals minus x is inferior to minus 1. Also, I'm going to add number 1 on both sides because we have exponent 1 minus x here. So I will have the following. I will have minus 4 is inferior to 1 minus x is inferior to 0. Here is the inequality number 2 here. Okay, so we have saved inequality. We have created the second inequality. Let's move on to create the third inequality. I'm simply going to add number 6 on both sides for this inequality. I get 6 minus 5, which is 1, is inferior to 6 minus x is inferior to 6 minus 1, which is 5. Okay, now we have third inequality. Let's name this one as an inequality number 3. Now we are ready to solve this inequality. Now we are ready to solve this equation. Okay, so now what to do? I'm simply going to raise 1 minus the x as an exponent for this inequality. Okay, so I get the following. I get 1 to the 1 minus x is inferior to 6 minus x, or is raised to the 1 minus x is inferior to 5 to the 1 minus x. Okay, so it's clearly this one, whatever the exponent is. If the exponent, even the exponent is negative, this one is towards number 1. Okay, this is the point what I'm looking for. Okay, since I get the minimum of this inequality number 1, we don't have to worry about the right side of this inequality. The right side of this equality must be bigger than this one. Okay, if it's not bigger than this one, must be equals to 1. Okay, because I'm doing this one to keep our inequality safe from the negative exponents, because once you have a negative exponent, you will have a problem. Okay, that's that's the point where we care of. Okay, so now back to the previous inequalities. If you take a look at the inequality number 2, you got the exponent runs from minus number 4 and 0. Okay, if the exponent equals minus 4, you will have the inverse. If this one, it's impossible to have 1 is inferior to this one. Okay, so value by value, it gets you to the 0 as a maximum. Okay, so whatever you replace here, you still have the inverse here. You have a problem. It's not an integer here. So the only way you get this one as an integer, the exponent must be 0. If you get the exponent 0 here, it gets 5 to the 0, which is 1. So it turns into equality. So this one must equals 1 in order to have this inequality work correctly. Okay. Also, so we have this inequality is squeezed between two integers, 1 and 1, which means we have this one equals 1, and also the exponent must be 0. Okay, now we are going to solve our equation simply. So we get 1 minus x equals 0. This one is given as a solution of x equals 1. Let's box this one in purple. So the second one in this one must be equals 1. So I get 6 minus x must be equals 1. So taking minus x to the right, bring back 1 to the left, I get x equals 5. Now we have solved our equation safely and successfully, and end up with these two following solutions: x equals 1 and x equals 5 are satisfied this following equation. So thank you for watching. I will see you next video. Bye.